everyone. How are you doing? Happy Monday night to you. Hope everyone is doing well. I am waiting for the lag time because, I got to see if I didn't mute it or not. But in any case, I want to welcome everyone to the room and to meet our special guest, Dr. Claudia Albers. How are you?
I'm very well, thank you,
Oh,
Wayne.
it is so
And
good to
how are
see you.
you?
I'm doing good. I'm doing good. We were just chatting prior to coming on here that you and I have communicated mostly by email for nearly 2 years now.
That's right.
Well,
Time flies.
actually, I think we're getting younger, my dear.
Good. That's a good.
So I just want to say welcome and thank you for coming on. I'm going to give this public confession here. The things that I have learned from you have aided me in my continuing journey of awareness.
Mm-hmm.
And you brought a foundation of two things. Number one, the purest language of the universe, math.
Mm-hmm.
That's what you brought into the whole Nibiru research.
Yes.
That, to me, established a precedent that no one else had. The second thing was that you brought an approach of science from an academic discipline that, again, expanded many people's awareness and definitely brought cognitive dissonance to others. So I just want to say thank you, Dr. Albers, and I can we call you Claudia?
Claudia's fine. Yes.
Okay. All right.
I prefer it, actually.
You know, actually, I'm hearing in the back of my head, humble pie, everyone. No. Anyway, so that's what you helped me to do. And I can't tell you how enriched that made me. So you have done, and I'm sure with so many others, just you've helped so many, and I just want to say thank you.
Well, it's a pleasure, and to me, it's wonderful because I am, first of all, a teacher. I love teaching other people and reaching them at a level that they can understand. And I think physics should be understood by everybody. If only all physicists used the language that everyone could understand.
Okay, so Dr. Albers, by the way, is a theoretical physicist. I'd like you to define for our audience, which is growing, let's talk about physics. In a very basic layman term, what is physics?
Basically, it's the study of what happens in the universe, how to explain it. So we observe things happening, and then we try to explain why they happen, and then use our explanations to try to predict what else can happen and how to build a whole picture of the universe that we're living in, how to explain it, how to understand it. That's basically what physics is about.
Okay, and so let's go a step further than that. So when we start trying to apply math, I guess is what we're saying, to what we are observing in our universe, that the math is going to help us basically to see if that is in fact going to be able to hold up or not. I think, and I'd love to get your opinion on this. So it's been stated in a lot of now of theoretical physics that dark matter doesn't exist. They can't find it.
Yes.
Go ahead. So,
well,
your thoughts on that?
I never thought it did exist. So I'm actually happy that they finally getting the evidence that it doesn't exist. I didn't think it did from the beginning. I think a lot of the astrophysics that they take as fact is totally wrong. And it's totally wrong because they refuse to accept certain small things that they should have accepted a long time ago. But instead, anybody who tries to publish in those areas is actually blocked from publishing. They don't want to know the truth. They have a view of the universe which is gravitational, which has been shown to be wrong.
Thank you.
And they just refuse to go there. So that's the problem. We have a case of the blind leading the blind in astrophysics. And I think that's what's happening. That's one of the reasons they don't want to know what's really happening in the solar system, that we have these objects that have come in and have changed things. They don't want to know, because if they start telling people the truth, if they do the research, then they'll find out that everything is wrong, or whatever theories they have, because it's all based on gravitation. These objects show you that gravitation is not the interaction of the universe. It's an electrical interaction mainly.
So,
but yes.
Go ahead. No, please continue.
Now, I was going to say, going back to the mathematics is basically a language. It's a language with which you can discuss logic, thought processes. It's easier to do it sometimes with mathematics, but mathematics can be used to lie as well. Like any other language, if you start from the wrong premise, you will end up with the wrong result.
Good point.
So math can be very powerful, but it's used by most physicists in a way that leads them in the wrong direction. So physics, and I used to train my students into a thinking process. That's what physics is all about. You are trained to think in a logical, step-by-step manner. So if you start at a certain point, you should be able to reach a solution. But it all depends on where you start. If you start with the wrong assumptions, you are going to get to the wrong solution.
So what I'm hearing you say from a layman's perspective is that we have been trying to build to a model, and I think they call it the standard model, right?
Mm-hmm.
That would basically apply the physics that have been brought up by theoretical physicists nearly 100 years ago into applied mathematics, all predicated on the fact that there is this thing. Thank you, Planet X News, $20 donation. We don't get donations in here that often. So that's like, everyone, we get a round on the house.
Yeah, that's Scott.
Scott, thank you, sir. Rascal. So if we can't apply gravity, and this is what everything has been built on, what does that leave us with? The electric universe, right?
Definitely. This is, I have been trying to believe in gravity as well, that everything is gravitational. But when I started observing these objects interacting with the sun, I could see they were not interacting according to what we would expect if they were interacting gravitationally. They were interacting through an electromagnetism, through a magnetic field. And if you have a magnetic field, you will have an electric field. So the first thing I discovered was the sun was actually going dark. To most physicists, that's totally wrong.
So can we just stop right there? Going dark. That's can we elaborate on that just a minute? Because that's a key point, because it definitely would affect the magnetosphere of our planet, right?
That's right. The thing is, it was totally surprising to me to discover that during the SDO eclipse season, the only possible way you could explain the images we were getting from the SDO satellite was that the sun was actually going dark for up to 69 minutes for 20 days at a time. So it had to be caused by something, and I knew it had to be an object that it was interacting with. But if the sun was powered by thermonuclear reactions, we would have light coming from the inside all the time, and it would be impossible.
I got that. I got that. Okay.
You see.
Key point, folks. Key point.
But the thing is, most people still think that it's impossible. But if you look at the images, you realize that on the first day of the eclipse, the corona of the sun shrinks back as the darkness advances across the face of the sun. And the only possible explanation for the corona shrinking back is that the sun is going dark. There is no other possible explanation. There is no way that the Earth could cover the sun so that the satellite cannot see it, and yet the corona is shrinking back. There's no way it can cover those little regions where it's obviously shrinking back. There's no way. So that tells you it's irrefutable evidence that the sun has to be going dark during that time. So the only way then is an electrical interaction, that instead of thermonuclear reactions, that the sun is ionizing its layer, its top layer. And through that ionization, it's that layer of material is emitting light.
Would that explain why we have a higher degree up in the coronosphere than we do at the surface of the sun? Is that the fact that
Yes, that's true, because what happens is it's the ionization that is creating whatever's happening on the surface, and that is creating high electric fields and causing these plasma loops to close. And as they close, they form high energy currents. And at those points, that's where you get the most heat. So the heat will flow upwards. And in fact, the sun must be cool in the interior and dark. And the heat flows up into the corona. Also, it's like, I actually found out that the sun has a liquid layer. So the photosphere is solid. That's why we have sunspots that are holes that are right through the photosphere. It's 300 miles in depth. Above that, there's the chromosphere, and the chromosphere is actually liquid. And it's boiling. Now, if you realize what happens at the surface of a liquid that's boiling, the liquid only goes up to a temperature of 100 degrees C in centigrade. And above that is the gaseous phase, where the gas can go to much higher temperatures.
Correct.
So we have plasma boiling off the surface of the sun, actually the chromosphere, which is above that, the liquid surface. And that's also why the corona is hotter. It makes perfect sense.
It does make sense. You know, I remember talking to a astronaut friend of mine, and one of the things that he always found interesting is that we don't realize that it wasn't until Skylab 1974 when they actually brought an X-ray camera up to Skylab. And you know, as Gene told me, he said the funniest thing was that we said it was as big as a damn train, it seemed like, and they brought it up there, and it was not a high priority experiment, but they did take the pictures for the first time where they observed something that we now call coronal holes.
Mm-hmm.
So my question to you from a layman's point, I've always wanted to ask this, is that could we be wrong in what we describe as a coronal hole, but is actually what we're seeing is in fact a much cooler region of the sun, and that these are growing in intensity and in frequency?
Well, I think they are cooler. They would be cooler because definitely the density is lower. There's less light being emitted from that region, so it's most certainly cooler. The reason why they form is actually because of the sun connecting to other stars. Now, I know they connect to the stellar cores. They could be it could even be connecting to a star that's outside the solar system, and it's a magnetic connection. And you have to remember the principle on which this is based is the fact that magnetic field lines always form closed loops. Okay. Now, they will tell you that at the surface of the coronal hole, we have magnetic field lines that are open. That is, they are perpendicular to the surface of the sun. But they cannot actually be open. They have to close somewhere because magnetic field lines always form closed loops. So where are they closing? Just very far away from the sun maybe, but somewhere. It means that the sun is connecting magnetically to another star. In this case, it's the stellar cores. That's why the percentage of the solar surface that's now a coronal holes is just increasing and increasing. And I've written about that as well. And it's because the stellar cores are stars, they produce magnetic fields, they connect to the sun magnetically, and if they are reasonably far away, they cause these coronal holes on the sun. If they come close into the sun's corona, then you actually can see the connection. It's like a root. And they draw plasma from the sun that way, through that connection.
And is this as well as why our sun seems to be burning much more now? Is it helium than hydrogen?
To tell you the truth, I'm not sure what the sun is doing. What I can see it's doing is that it is extremely weak.
Yeah.
It has lost a lot of its light emission, especially from the chromosphere. And that doesn't surprise me because these objects actually connect to the sun right down to the chromosphere. And the plasma that they draw from the sun seems to come from the chromosphere. And the younger and the stronger these objects are, the further down into the chromosphere they will draw their plasma, to the point that sometimes they actually leave a blemish on the sun.
Now, and this is just me thinking as you were talking. So when we talk about the ionization of the sun itself, isn't a byproduct that would be a heavier, denser ion that would then begin to basically fall into what I would call the center of the sun, the core of the sun?
Yes, what happens is the sun produces an electric potential. So there's an electric potential across the outer layers of the sun. And that, like in a cathode tube or an ionization chamber,
Yep.
produces a potential difference which ionizes the gas. So the sun's outer surfaces are ionized because of this electric potential. And when they ionize sufficiently, then that plasma will go into arc mode. And it will emit a lot of light. It
Right.
will get very hot and emit a lot of light. What else happens is you may then get fusion reactions. I think it may be cold fusion that is aided by the electric potential. We could have fission reactions as well.
Wow.
Yeah, so all of this is happening in the sun because of this very high ionization. So this is also why it's so hot. There's so much energy released. Elements are produced. So there's fusion, there's fission. So they break down, they build up. All this is happening on the sun. That's why there's iron in the sun's atmosphere. There's all kinds of elements that are being produced in this hot oven that is our sun. But it's all due to ionization, I believe.
And also what we're seeing that is as well is it's kind of a boomerang effect, is that we're getting dosed with more intense radiation from our star, but as a result of the interruption because of its magnetic what's the word I'm looking, variations, I guess.
Its magnetic field.
Yeah, thank you. It's impacting us. And as a result, now Earth is getting doused, with cosmic radiation coming from the core of the universe.
That's right. All of that is
That'd be
happening.
good.
Yeah, the sun is weak, so we are getting more cosmic rays from the rest of the galaxy. But the fact that we have coronal holes means that we are getting these high energy particles coming from the sun itself. So the sun has become a source of high energy particles. So basically a source of cosmic radiation itself. And then we have all these other stars in the solar system that are emitting radiation as well. And then on top of it, our magnetosphere is under extreme pressure. And it seems to be allowing a lot of radiation through. On top of that, our ozone layer is depleted. And what they are using, the chemtrailing, the aerosols, and what they are using to actually stop people from seeing what's happening is further destroying the ozone layer. So we are getting it from every end.
So I want to share this with you. I just recently had a very good conversation with a person that was saying much what you're saying, that not enough study is being done on what this is doing to our Earth, because with these increased heavy particles hitting the Earth, hitting us, and coming, as you said, from our sun that we're really getting doused with. All right, can we then begin to extrapolate that? Would there be a accumulation effect of radiation in the core of our Earth as well?
Well,
We're talking
definitely.
energy, right? We're talking energy particles, right?
Yes, the way it gets to inside the Earth is, first of all, through induction, because if particles impact our magnetosphere and they're very energetic, actually they go right through, they end up impacting the ionosphere. And then they ionize the atmospheric molecules and atoms in the ionosphere. And then these are charged particles. And as they move, they create currents. And then if you have currents up there, they induce currents in the lower atmosphere, on the surface of the Earth, and inside the Earth. Nothing can stop induction from happening. And the moment you have induction, you have currents. And always, whenever you have charged particles being accelerated, moving in a circle, perhaps, you always have creation of photons. Light is emitted. So whatever we do, it's going to create radiation, electric fields, and so on.
Now, in through the theory, the principle of induction means that there also has to be an outflow of which that energy is then transferred, correct?
Yes, well, it induces an electric field somewhere else.
Right. That's what I was trying to articulate.
And
That
the
was just a
electric
steiger.
field, no, that's fine. Electric fields means it causes particles to move. Inside the Earth, especially if we have areas that are not such good conductors, what happens is the charge will build up until eventually you get a discharge. And it's like lightning, it's underground lightning. And then this discharge will actually break up rock and create an earthquake.
Is that why we see lightning many times prior to an earthquake?
That's right. That is correct. And we actually see lights building up on edges of mountains, on points. And that's because of the buildup of the electric fields to do with this increased charge that's building up inside the Earth. Also, if you've seen in volcanoes, whenever you have volcanic eruptions, sometimes you will see lightning associated with the lava that's coming out from inside the Earth. Yeah. Don't forget that lava is actually molten rock. It's rock. It shows you that you can have lightning associated with rock. And at that time, we can see it because it's above the surface, but the same thing happens underground.
This is fascinating science to me. Now, when we talked about this, now let's start taking this out into what's happening to the Earth as a planet. What is happening? You know, I say to people all the time, it's not so much Nibiru that I am concerned about. It's more the brown dwarf that it's sitting out there in the Oort cloud somewhere that we haven't discovered yet, but we're feeling the effects of.
Yes, but the thing is, we have had quite a lot of brown dwarfs coming in, and I think we still have more of them come in. and coming in. We have a whole system of them that seems to have invaded our solar system. And I reached the conclusion they may have started coming in about 150 years ago.
Holy crap.
Yes.
I'm sorry, folks, but I mean, that now see, that I can hitch my wagon up to. That's a horse that I can back. Now, let's talk about the implications, because now I'm thinking in my head, Claudia, I'm immediately thinking, let's talk about the impact to planets like Jupiter, Saturn, which let's be candid, they're still an anomaly to us. Are they or are they not? Now, you just recently wrote a paper on Jupiter, right?
Yes.
Go ahead. Can you, I'd love to hear it.
Well, I was actually, I read a paper about someone doing a survey of the Orion Nebula, and they were looking at brown dwarfs, and they were detecting brown dwarfs by the fact that, well, from their temperature and from the fact that there was water in their atmosphere. And I thought, oh, that's very interesting, because I know that a lot of the brown dwarfs are very likely to be brown dwarf stars. In other words, old stars instead of stars that were born as brown dwarfs.
Ah, okay.
Because of what I've seen of the stellar cores, they actually do a lot of things that we associate with brown dwarfs, like they have jet ejections. Some of them have striped appearance. They have all kinds of things that we associate with brown dwarfs. And I've always thought from the beginning that a lot of them are actually the same object. But they just have never, the ones that are in the solar system are usually ignored by, the astrophysicists. They rather would rather look at the ones that are couple of light years away, 60 light years away, 1,000 light years away.
Instead of something that may be, in fact, 1 or less light years away.
That's right. But they always compare them to Jupiter.
Now, why is that?
Because apparently they always say they're somewhere between a low mass star and a gas giant planet. And there are many similarities. They have the striped appearance, they are large, they have this kind of gaseous atmosphere with a lot of methane in it, and so on and so forth. And then I looked at Jupiter and I thought, but wait a minute, Jupiter is known to have water in its atmosphere.
And striped. And striped.
Yes.
And striped.
That's right. Now, how does water form in the atmosphere of Jupiter? I believe it's the same way that it forms in a comet tail. And it's not ice. I don't think comets, and I've written about this as well, comets are actually like asteroids, but they are electrical. And so when they have an elliptical orbit, their potential changes. And when they changes, they start ionizing the material around them, and that creates the tail. And so they have oxygen in them, and most of these stellar cores have oxygen in them. And if this oxygen is ionized, and then it picks up protons from the solar wind, which are hydrogen nuclei. And when you put together oxygen and hydrogen, what you get is water.
H2O.
So this is how water is actually formed. It shows that the object is able to ionize oxygen in its atmosphere.
Is that and that's the result of the plasma fusion
that's right.
taken? Okay. All right.
So what does a star do? Like I said before, a star, how it produces light is it ionizes its outer layers. So the fact that Jupiter is ionizing oxygen means it's still able to ionize its outer layers.
I see where this is going. Okay, this is cool.
Yes, and it emits a lot of radiation still. It emits radio waves beyond what it should be emitting as a planet. So basically, it's acting quite a lot like you would expect a star to act, except it's now very cool and weak, but it shows that it was most likely a star once that has aged to the point that it looks like a gas giant planet.
How interesting. Is there
So
enough, do you think, reaction that it could something one day change that the electrical field and cause a reaction to start within the core, let's say, of Jupiter? Or
from
is
what
that
I've observed, these stars that age do not actually ever go back to igniting again.
okay?
And lately, I came up with this idea after looking at the expanding Earth, that there's mass creation going on. And in order to explain mass creation, I had to go into aether.
Oh, really?
Yeah, I had to
I love
realize that
this.
what I think stars and celestial bodies are doing, and maybe not all of them, but some that are able to are absorbing aether particles, aetherons, and they are transforming aetheron energy into other forms of energy, electric potential, generation of magnetic fields, and so on. So stars seem to be good when they are young at doing this transformation, but when they get old, they're no longer able to do it. So the stellar cores that have come into the solar system and possibly Jupiter have aged beyond the point where they can do this easily.
I see. That
So
would
this,
mean that we're a very old, ancient solar system.
yes, I think so. I think the universe um, is possibly of infinite age. Um, I don't believe in the Big Bang Theory. I think it's been falsified.
I agree with you on that. It doesn't ever make sense to me. By the way, again, you're good for this channel. I mean, there's another $10 donation. So,
It's wonderful.
ah, well, thank you, thank you, thank you. So,
Yeah.
okay, so the universe itself is of infinite origin, and I agree with you. If you got the Big Bang, I mean, what was before there? There had to be something.
Yes, the biggest problem with the Big Bang is that you have creation of mass from nothing.
Yeah, how does that
Phys-
work?
Physics breaks down completely whenever you have a singularity. It cannot be described at all. So you actually need faith to believe in the Big Bang Theory. And it's all based on the fact that redshift is all about recessional velocity. And that's been proven to be wrong. You often find objects of high redshift connected by dust to objects of low redshift. And this, there are hundreds and hundreds of examples of this. So for astrophysicists to continue to believe in the Big Bang model, they have to have a faith beyond any Christian. They have to have faith and ignore all the evidence.
Oh, high five, girl. I mean, come on. Folks, that's worth the price of admission coming in. I love that. Okay, this really now begins to make sense. So when we think about, all right, so creation,
Mhm,
that opens up a whole new approach.
mhm.
I'll let you continue.
Well, the Earth seems to be expanding. It's actually been calculated. There was one study I found where they actually showed that the ocean is growing in size by 0.4 millimeters per year. They actually measured it. And so the Earth seems to be expanding. And how do we explain the fact that the Earth is expanding? Possibly through matter creation from the inside. But it's not the only thing. Before then, Halton Arp, the astronomer, he wrote this book, Seeing Red, that I just absolutely love. And he showed that, first of all, redshift is intrinsic in nature. It's not to do with recessional velocity. He has hundreds of photographs in his book that show this. He showed that the only way to explain what happens from the center of very bright galaxies, so galaxies with active galactic nuclei, is that they create matter, and it's episodic. That is, they eject matter along the minor axes in opposite directions. And then this matter condenses into quasars. And then in the course of time, these quasars unfurl arms and become galaxies in their own right. So galaxies are giving birth to other galaxies. And also the reason why quasars unfurl arms is because they continuously eject matter from the center. And so matter is coming out from the center of these quasars all the time. And that shows this matter creation. There's the episodic matter creation. And this matter creation is of zero mass. And then as time goes on, the mass increases. And that can explain what we observe as the redshift, which is extremely high when objects in the universe are young. They've just been created. That's why quasars have such high redshifts. And then as they get older, the redshift drops. So all the galaxies have lower redshifts. It's nothing to do with the distance from the Earth or the fact that the universe is expanding. It's to do with the age.
So that just, as you were just talking, I am asking myself, so would we see a difference in speed of a younger star system as opposed to an older one? It would seem like if mass is impacted by speed, right? Because I've never figured out how you keep the same acceleration, but let's say if the mass density continues to increase, wouldn't that slow it down?
That's right. So in the beginning, it moves at close to the speed of light. It's
Right.
ejected from the center of the galaxy at close to the speed of light. And then it slows down as mass increases.
Wow.
But in the end, they stay as companion, what are called companion galaxies. So you have this big galaxy in the center with a low
Yeah.
redshift. And then on either side of that, you have these smaller galaxies of higher redshift. And then these smaller galaxies eject other galaxies. And so you get two other galaxies next to that. That's why you get a line of galaxies across the universe.
And it
That's why
seems
they
like some of
form.
those nodes are bigger than others.
That's right.
I love this. Oh, this
So
is just so cool.
yes. Well, you do get a little bit of an effect due to their velocity with respect to each other. There is a little bit of a small part of that redshift may be described as being due to relative velocity, but it's only a very small part. Most of it is intrinsic. It's to do with the mass of that matter.
Can I ask you, do you think that I've been reading about graviton waves and that the new science on this is explaining that if we can detect one type of wave, which is a new classification of energy, that how many other waves are we not even aware of?
Yeah, that's true. If we go into radiation, gravitational waves are a little bit different in the fact that they are not radiation. They are actually fluctuations in the space-time continuum itself.
Okay. Okay. That's what I was trying to say. Is that because I've never figured out gravity. No one has ever explained to me how the moon stays up there.
That's right. It's not easy.
How does that, Dr. Albers? How does the moon stay up there? Someone in the the room's going,
Well,
come on, Wayne. Duh.
if we were to explain it with gravity, we would say that the moon is actually in free fall. It's falling towards the Earth, but it has such a velocity that it always misses. If you throw something up in the air, it will go up and come down. Well, the moon is doing that. It's falling down towards the Earth, but its velocity, horizontal velocity, is such that it keeps missing.
Okay, that's gravity. So what's the
That's
real
what the
thing going up there?
The real reason, the thing is, gravity is actually a weak electrostatic force.
Ah, thank you.
So it's actually due to the charge of particles and the fact that matter can be polarized all the time. So even though you have neutral atom, if you separate the nucleus, which is positive, from the negative, which is the electron, so one moves to one side, one moves to the other, now you have a dipole. Now this dipole can attract another dipole. That's polarization of charge.
Yes,
So
I know what that is.
that's
Okay.
right. So when you polarize matter, you can actually have matter attracted by other matter. And you can also see that all these interactions we have between matter are always electrostatic. Because if you try to push your finger into something else, a piece of matter, what stops your finger from going in? It's electric fields.
Yeah.
It's the electrostatic interaction of matter itself, and the fact that your finger is repelled by the surface of that material. It's all electric. So gravitation is electrical as well. And the thing is, it's very nice to think it's constant across the universe, but it cannot be. I think it's constant within a solar system that's in equilibrium, because all the matter got generated from the star itself. If there is more than one star, the star is fissioned. If there are planets, they actually formed inside the star, came out from the star. They are all the same matter. They all therefore polarized to the same degree. And therefore, the whole system is in equilibrium, and gravity seems to be constant within that system. But then when we have these stellar cores coming in from outside, you realize, but wait a minute, they're not interacting gravitationally like all the planets are interacting with the sun. They're actually coming up to the sun, not colliding with it, coming up to it, interacting with it, being attracted up to a certain point, but not actually colliding with it. So there is a balance of forces there. They are attracted, but they are repelled, so they don't collide. They're not going into a very fast orbit around the sun, which we would expect if they were interacting gravitationally. Sometimes they actually are seen to move away from the sun at a fast pace and with CME plasma at the same rate as CME, the same velocity, even though they have to be so much more massive than the CME that was ejected, the CME plasma. So that shows that what happened was there was an electric interaction. When a CME happens, suddenly the electric field becomes quite huge. When that electric field becomes huge, you create an electric repulsion between the coronal, the CME plasma, and whatever the stellar core is made out of. The matter reacted to the electric field that suddenly arose on the sun, and it got repelled, and they all got repelled away due to that charge that built up on both the CME plasma and on the stellar core. So you can see it's an electromagnetic interaction.
Well, yeah, and that's what I was just looking at. When you see, now you said something in that the solar system, because of the sun, forms an equilibrium.
Mm-hmm.
And in other words, there seems to be this ebb and flow that keeps it. The question I have, if we look at something like Nibiru, we look at, one of the theories I'm postulating is that we know that the Milky Way is consuming the Sagittarius dwarf ecliptical galaxy that's been going on. That I contend we don't have the knowledge, we don't have the instrumentation to warn us if, as you had said earlier, that we have entered into a different quadrant of space itself, that where the density of brown dwarfs, the density of let's say, other systems. Um, that's what I think that we continue to see,
Mhm.
Claudia. And if it's Nibiru, if it's part of that, I don't know. I just know that there's something out there. I've seen it enough. You and I have conversed over the years enough. I know that there is something out there.
Yes, the thing is, we have been taught a totally wrong view of the universe because our solar system has been invaded by objects before. There have been cataclysmic events in our solar system before. And so I don't think our planets have always been in the same arrangement that they are right now. We've been told everything's fine, nothing's ever going to happen. Our solar system is safe. The next star is 4 light years away. And we live in a universe that's mainly empty space. I think that's not true. I think that our galaxy may have a lot more objects that may not be as visible as we would like them to be. So we haven't seen them before. Our telescopes could not see them. And it, it's full of these objects, these stellar cores, these old stars that are no longer emitting much light. And it's only a matter of time before one comes in. Like I said, Jupiter and Saturn may have come in ancient times and they have perturbed our solar system in many ways. We were not around to
Yeah.
know that. But when we were taught, no, nothing like this can happen, even though it was in the historical record that it had happened before, that something had happened. We know that there have been asteroid impacts.
And
Uh,
comets.
we know that these things can happen. We should
Yeah.
have known, but we were taught to feel completely safe. Nothing's ever going to happen. And so the truth continues to be hidden from the Earth's population of what's actually happening.
Well, I mean, you and I were talking before we went on. I mean, the asteroid belt.
Mhm.
Now, I was raised in science that there was not enough mass. Now, how they projected that, I'm not sure, back in 1970s, that it could have ever been a planet. However, the new approach to this is that, well, wait a minute, it may have been more than just one.
Mhm.
So there has been a collision in our solar system. Now, whether that has been, hundreds of millions of years ago or in more recent times, I don't know.
Mhm.
So it shows that we're very susceptible to that.
Yes. I mean, even the accepted theory on planetary formation does not have room for these rocks to stay in place without coalescing into a planet in the middle of a planetary system. It just does not make any sense.
I
Why
was just
would
connecting the dots on that one. That was good.
you see? So it would have formed a planet, even according to the accepted theory, where you would have all these rocks that coalesce into planets. And even, I don't believe in the accepted theory at all, because when you have impacts between pieces of rock, what actually happens is they shatter into smaller pieces. They don't coalesce.
Yeah, exactly. So they're trying to use a different type of science to get that one right.
It's all
Very
it's
good
all
point.
based on gravity. They think that gravity will hold these objects together. But have you ever seen two asteroids collide and stick together?
No, no, no,
It
no.
doesn't even make sense.
I'm still trying to figure out how some of these asteroids are always peanut looking like. How does that happen in nature? I mean,
Exactly.
it doesn't make any sense.
No.
So let's talk about the theory behind rogue planets. I
Mhm.
mean, there's so much, the whole subject of Planet X and Nibiru has now taken on, the status of, becoming mainstream in our thought process. So what is the likelihood that there is, in fact, a rogue planet that would be in an elliptical orbit or whatever kind of an orbit that where it would actually come through our system again?
Well, it's possible. The
Yeah.
thing is, I don't have enough data to tell you whether it will come or whether it's ever been here before. I can only observe what's here right now.
Right.
So I can tell you, well, the historical record shows that things have happened before. They will not necessarily happen the same way.
Could it be our twin star out there, Claudia? Could it be our binary twin that we're actually seeing the effects of?
It's possible. Most star systems are binary, or at least binary. Some of them have 3, 4 stars in them. And this is because stars fission. You cannot explain that with the gravitational theory again, because a cloud of dust cannot gravitational collapse to 2, 3, or 4 different points at the same time. It can only collapse to one point. So the fact that most star systems are binary or trinary or have even more stars in them shows you that it's not gravitational collapse that leads to stellar formation.
Interesting. I love this.
So, but it is possible that the sun has a binary twin or even more stars in the system. And of course, it would be affected by it. It would at least interact electrically and magnetically with it. Definitely.
I was just thinking as you were talking, we have, all right, the gas giants, Jupiter, Saturn, Neptune, Uranus. I've never thought about this, Claudia. Could those planets out there, could they also be an attraction to, let's say, something that's going by in the local neighborhood, be influenced by the mass of those gas giants?
Well, certainly, although they're not nearly as massive as the sun itself. What would attract a star going by would be the sun itself.
The sun itself. Okay.
But like I said, it's not about mass. These objects are attracted to the fact, or these old stars, to the fact that the sun is still producing its own energy. And they are parasitic in a way. They attracted to that energy so they can absorb it. That's why they come right up to the sun and congregate in the corona so that they can absorb its energy. They are attracted to it.
Parasitic. That's a great word. I don't think about that often. So our sun is really old, isn't it?
Well, I think it is quite old. It's not nearly as old as these other stars that are invading it. I think these stars are much older. I think our universe may have a whole lot of very old stars in it. So, wow. And they have become dark, so we don't see them. So there may be a lot of these in our galaxy that we don't see them. And so it's a system of these that has invaded our solar system. It's possibly still invading it. I think there are some that are still coming in because they are dark initially, and you can actually see the difference in the sun's corona. Some of them are still dark and making the connection, whilst others have started emitting some light.
This is, as you think about it, you begin to add the implications as we begin to observe these. I know Mike Brown over at Caltech has done a lot of study in this. You have your background and your research in doing study this, and we're finding that it's a much crowded universe out there.
Very, very different universe from what we have been told. We've been told that gravitation is the same throughout the universe. The speed of light is the same throughout the universe. I don't think this is so at all.
As you were just talking, explain to me the Oort cloud. I mean, to me, when I've been doing the research in it's this theoretical, huge mass out there.
It's supposed to be a bit like the asteroid belt, except it's supposed to form a shell around the solar system. There is actually no evidence that it exists, and Carl Sagan did not believe that it did.
Wow.
And the theory came about because of the comets. The comets come in towards the sun on a very elongated orbit. So they seem to come further from outside the solar system, but they didn't want to say they came from outside the solar system. So they came up with a theory that we have this Oort cloud, where these comets on very elongated orbits come from. And they now and then are just pushed out of their orbit and they come in towards the sun. But I actually believe, and a lot of astronomers believed, even Carl Sagan did, that these are actually objects that come from outside the solar system. So they may actually be part of these stellar core planetary systems, and they may be coming in from outside. So the Oort cloud basically is a theory. We don't actually have clear evidence that it exists.
Wow.
It's based on the observation of comets coming in towards the sun.
Think about this. We got over 300 people in the chat room, Claudia. And think about this, folks. You have had the best lesson in understanding physics, astronomy, understanding theories on the formation of our universe, the current theories that are being taught and how it's so backwards. Claudia, this is amazing when you start thinking about it. So we really don't know what's really too far outside, let's say, of Pluto, right? I think, what is Voyager 1 now? It's, I guess, somewhere there in interstellar space now. Is that right?
Mm-hmm. Yeah, there's very little we know about our universe. And we are not helped by the fact that no one wants to study what's really going on in our own solar system, where it would be easy to observe and measure. But no one is interested because something amazing is happening in our solar system, and it's actually very dangerous. And the powers that be don't want us to know about it.
So let's talk about that. What is happening? Let's get it out here. So, because people, it's filling up here, and people are loving you, by the way. I got to tell you, my dear, you're a hit.
Yeah, thank you. It actually all started, Scott, I work with him now. He was the one, he started before I did, looking at all this. And together we built up all
Scott is with Planet X News, right?
That's right. So we work together.
Subscribe, folks.
Yeah. And he's really good at helping me to think about things as well. It's very intelligent. And so we've gathered a lot of evidence about these stellar cores, and is always finding more and more of them in the sun's corona. It's amazing. But the thing is, what they are doing is they are draining the sun. So our sun is basically dying because of it. It may have survived a long time ago when other stellar cores came in, perhaps Jupiter and Saturn. And it weathered that, and those stars eventually ran out of energy, could no longer connect and draw energy from the sun, and settled down as gas giant planets. But the system that has now invaded our solar system is huge. There are too many of them. And I see signs of the sun, the solar activity declining, and it's declining independent of the solar cycle. So it's the minimums seem to arrive early, the maximums are late and ever weaker.
And longer.
That's right, and longer. So the sun, I think a lot actually of what's actually happening with it is being hidden. I've written some articles about the fact that they add things to images all the time in order to hide that some things that may have shown up here and there. The images are being manipulated, the LASCO images, the Core 2 images, the SDO images, they're all being manipulated. It's only now and then that we see what's actually happening.
That's fact, folks.
And it may actually be the tip of the iceberg. I think the sun has become much darker than it used to be. It's actually not emitting, going dark now and then, fluctuating in light emission. So it's getting weaker and weaker and weaker, and it may die. It may become a stellar core itself because too much energy is being drained out of it. And if the sun stops, these stellar cores will stop as well. They are dependent on it for whatever energy and light emission they have managed to gain through what I call a rejuvenation process.
It's so vampiric, when you hear the
They
vampire
are.
analogy, it's just, I'm seeing that my God, could you imagine a species of life forms that take the form of these stellar cores that are vampiric in their approach?
That's right.
Suck the life right out of it. Now, we're talking in time, are we talking millions of years, et cetera?
Well, to tell you the truth, the way I see the sun, I cannot actually predict, but I would say it may take less than 100 years before it's completely dark.
Okay. Let me go get my bottle of tequila. I'll be right back. No. Okay. All right.
I cannot be certain, but
No. I mean,
from the
listen.
way it's just weakening,
Yeah.
I believe it may happen within less than 100 years.
Listen, I believe that our planet, Earth, and I believe most planets have this ability, Claudia, that have the ability to generate not only heat underneath, but light as well.
Mm-hmm.
And that we don't have a solid core. In fact, I don't think we really know what we have down there. But the fact is that I don't think you necessarily need a sun per se to have life on a planet.
Yeah, that is true. Don't forget, Pluto has shown that it is being warmed from the inside.
Bingo.
And Pluto is right out there at the edge of the solar system. And our planet is active as well. It is producing a lot of energy. The energy in the liquid outer core is supposed to be about 6,000 degrees Kelvin, which is about the same as the photosphere of the
I was going
sun.
to say that's warm, sister.
That's right. So our
Let me
planet,
get my SPF 5000 on here, folks.
and actually our planet has warmed up due to the influence of these objects that have invaded the solar system because of the induced currents within the inner part of our planet. In fact, all planets seem to have warmed up in the solar system due to the presence of these objects. So the Earth is actually warming up from the bottom, and it's causing these volcanic eruptions. And that's warming up the ocean. And this is why our planet is warming up and why we have so much of the ice sometimes melting in the North Pole. It's because the oceans are warming up. But now it is possible that our atmosphere becomes cold. So
Well,
we
you
would
had talked
have.
about the equator on the fact that our planet is expanding, right?
Mhm,
So that water displacement is going somewhere,
mhm,
right?
yes.
I have a friend. I've been trying to get a hold of this gentleman down in Florida. He is recording, Claudia, their local bays emptying.
Yes, I've written about that as well. That is what we expect to happen because of the induced currents, because our ionization is getting more and more ionized. So we are getting more and more induced currents on the surface and on the surface of the ocean as well. And then because we have induced currents and water is actually a natural dipole, it will move along these electric fields that are induced in the ocean. And that will produce tidal events. So one region, the water will move away from, um, it will move away in the direction of the electric field. And in other regions, we would get piles up of oceans. So that will mean we get large waves coming in or
And we
tsunamis.
have, and we're seeing that.
Exactly.
Yeah, we
So
are.
that's exactly what's happening. That's because we are living in an electrical universe. Because everything is electrical, everything is to do with electrical currents.
So I'm going to be showing here in the next week or so, and I was telling you, Claudia, this. Brenda has been doing some fabulous research, and Claudia, it's very clear to me from all the research that she has been sending and doing that we are now in the midst of what it appears to me to be a magnetic pole shift.
Mm-hmm.
Would
Yes.
you say that there's indications for that from your perspective?
I would say so. That would be one of the effects because we have extramagnetic fields and we have
Thank
these
you.
objects whizzing around and affecting the Earth's magnetic field. So, of course, it's going to change. It's going to affect our planet's magnetic field. It's going to cause a shift. And that's what we've seen happening. It's shifting, and it will actually cause the Earth to wobble and tilt in a certain direction
Thank you.
because the geographic poles are aligned to the magnetic poles in a certain way. It's not quite understood why, but again, I would say it has something to do with the electric interaction. And so they are aligned, they're always at the same angle to each other. So when the magnetic poles shift, the geographic poles will shift with them as well, and that will tilt the Earth.
And wouldn't we see low pressure and high pressure systems that would basically follow that electrical current, so to speak, which we see in
Yes,
the jet stream, but that would be
yes,
shifting.
that's right. They will shift, but it's also to do with currents because we have low pressures. We have an electric field that is induced so that water molecules spiral along that magnetic field that is induced. That is a straight line straight up towards the ionosphere. And the water will spiral along this magnetic field line and move upwards. That's above a low pressure region. And that's to do with the direction of the electric and the magnetic field that are aligned. So water will rise above a low pressure, and that leads to cloud formation. There's a reason why clouds stay aloft. And don't forget, they are made out of water droplets, and water droplets are much denser than air. How do they stay up there? Gravity pulls them down. They
Well,
stay up
now you're
there.
going to ask those questions.
Exactly. It's
Yes.
all electrical. Weather is electrical in nature as well.
Got that right. I can tell you. Now, see, it's that type of cognitive reasoning that, we never think about. Well, we see the clouds up there and it's like, oh, well, we're used to seeing it and we never think anymore. But there are dynamic changes
Mm-hmm.
taking place. And that's what I think that what we've been talking about. And it's so much, it's such a large topic, and it includes so many things, Claudia. It's amazing.
It is. Well,
Oh,
it's taken me some months to, think my way through all this because I was trained like any other physicist, believe that everything is gravitational.
yeah. Well, I think there's more and more coming over to that camp. And I think that the more that they do, I think our science is going to be rewritten. And I believe then that we're going to come out with a whole lot of new theories of approaching old problems.
Mm-hmm. I believe
Well,
that.
it's been over an hour. Claudia, do you have a website? Do you have a YouTube channel?
Well, Scott is in charge of a website. He's got a website.
Okay, so is it Planet X News?
Yeah, if you go to Planet X News, under all the videos, there are links to all the websites.
Okay, all right.
He puts all the news articles on there all the time. He's very diligent with that,
He's a good
and
man. He's a good man.
yeah, he is. He's excellent.
Known Scott for years as well.
Yeah, he does a brilliant job. He's helped me so much. He's helped me come to the United States, and he's been a great help.
Well,
And
I'm glad you're here. I have to
yeah.
say, you were at one time over in South Africa, and it's just a delight. Will you come back on?
Yes, of course.
Okay. And, I do. And now here, folks, here's my shameless plug. I'm going to do this is I would like you to, I have a weekly show.
Mhm.
And where am I at? There I am. So I'd love to have you come on the Steiger perspective as well
Hmm.
and come back on the channel here. I know people, I can tell you, they just love you. They just absolutely love you.
Thank you.
And I know this. I there's so much I could say that
Mhm.
you have brought to all of us. I'm glad you're here. I'm glad that Scott is there with you. He's the right person, and you bring a knowledge. And
Mhm.
so one person did ask, and I thought I'd throw this out there to you. They would like to know, how come does Saturn have hexagon poles?
Well, that has to do with, of course, the electric interaction, of course. I cannot actually tell you why exactly they are hexagon shaped, except that the symmetry of the magnetic field must produce that.
Oh.
Um, don't forget, the magnetic field is always stronger at the poles of a celestial body. And I know that it always produces a toroidal shape because the magnetic field is weaker around the equator. And where the magnetic field is weaker, we always get an expansion of the matter itself. It's actually the magnetic field that contains the matter of a star or a planet. It's all magnetic in nature. And that's why white dwarfs are toroidal in shape, and why young stellar cores have toroidal envelopes as well. And the fact that it's a hexagon has to do with something else that's possibly happening with Saturn. And like I said before, I think Saturn is actually a very old star, and it may be producing some kind of electrical interaction on top of its magnetic field, which is then producing that hexagon.
Wow, we have to come back on this because I was just thinking, when we see in the XYZ cut on integrated weather services where we can actually see the models,
Mm-hmm.
that is something that, yes, we're going to have to talk about
Okay.
again. All right, everyone, thank you for your kindness. I can just tell you, Claudia, people have absolutely just fallen in love with you. They
Oh,
just,
that's, thank you. It's
um,
been lovely to be here.
you have been, well, all I can say is thank you. I am wiser every time I get around you, whether I'm reading your emails, and now that we can have you on more often, I
Mhm.
feel like I am getting a free education.
That's wonderful. It gives me great pleasure to teach people. I
You are a
enjoy,
teacher.
yes, I'm a teacher by nature. I enjoy teaching people. I enjoy understanding it, but the truth is, it's only when you try to teach somebody that you actually start learning.
Well, you've educated this community. We're going to have you back. Let us know what we can do for you. One of the things this community does do is that we try to give back those who given to us. So
Mhm.
anything that we can do for you, you let us know.
Well, I know that Scott has this thing where he's selling shirts,
Okay. All
and
right.
we use that to raise money. We thought it would be good because everybody needs clothes anyway.
Don't they?
And at least it's not just giving away money, you get something for that.
Okay.
So,
I can dig that. Hey, listen, people have been asking me to get my own t-shirts, and I think that this is something. So tell Scott to leave me a link, send it to
okay.
me in the email, and
Mhm.
I'll post it, and we'll sew into yours and Scott's life as well. And thank you. And
Thank
that
you.
way we know you'll come back as well.
Yes, of course.
All right,
I will.
everyone. Blessings to all of you out there. Thank you. Tomorrow night, we'll be bringing Sharon on, and we're going to be talking about some pretty serious issues. We're going to be talking about um, cancer and how what we're seeing in our environment today, the changes, Claudia, that you and I have been talking about,
Mhm.
and how this is beginning to impact our bodies and
Yeah.
other topics as well. So don't miss that as well. Again, thank you, Claudia. Thank you, everyone. Have yourself a good evening, and we will see you again real